So I want to talk to you about molarity, and obviously Miss Donovan isn't here, so this can be paused whenever it needs to be paused, so you guys can write stuff down. So molarity is a way that we talk about solutions, or at least the amount of stuff inside of solutions. So our goal is you should be able to tell me qualitative and quantitative terms when it comes to molarity, which again is just a number way of describing solutions. So again, this can be paused so that you guys can have some chance to finish this up. So if we describe solutions, we can do it one of two ways. We can either use numbers or we can just describe it with words. And if we go for a qualitative, a non-number approach, the terms that we tend to use are the words diluted or concentrated. And you guys know what this is. So if you wanted to get a soda at Costco or something like that, you could have it when you drink it, you're like, oh, that tastes right. Or sometimes it's, oh, this doesn't taste, it tastes like a bland soda, like it's kind of watered down. That is diluted. Diluted is when it's watered down. There's a lot of solvent, and comparatively, there doesn't seem to be much solute. So solvent is the stuff that does the dissolving. Solute is what you're dissolving. The opposite could be concentrated. And that would be, wow, this one tastes really strong. So it's like if you were to get, if sometimes, and it doesn't happen too often, where if you get a soda, it actually tastes too overpowering. It's like, oh, this is way too sweet. Or if you get tea or coffee and someone puts way too much sugar into it, you're just, oh, that's way too strong. It's way too sweet. It's way too concentrated. That's when you have a lot of solute, the stuff being dissolved, compared to the solvent, the stuff doing the dissolving. And again, feel free to pause. If we do this in a non-qualitative way using numbers, what we use is something called molarity. Molarity is this capital M. So the term is molar, so it's a molar solution. So I would say this. 1 molar solution is greater than a 0.9 molar solution is greater than a 0.1 molar solution. The unit is molarity. Molarity is the number of moles. So that was that 6.02 times 10 to the 23rd thing that we did a month plus ago, out of the total volume, or the number of liters found inside of the solution. So it's moles per liter. That's what the capital M molar or molarity turns out to be. Liters of solution, that's easy because you just look at the number. To figure out moles, that is the grams out of the molar mass. And remember, molar mass, just we look up the numbers from the periodic table. One of the things that also will throw you off is typically we don't report solutions in liters. We'll talk about it in milliliters. So I won't have a 0.6 liter solution. I'll have a 600 milliliter solution. So we have a few things that we have to keep track of. First one is we have to figure out moles, which isn't hard. The second one, which is just tricky, is we have to keep track of volume. One of the things is, why do we make solutions? And we make solutions because it makes reactions easier. It's just easier all around if we have solutions. Where do we use solutions? The better question is, where do we not use solutions? Some solutions are kept in molar solutions. Some of them are kept in normal solutions, which is a totally different thing. Or there's variations on these, which would be like percent solutions or grams per gram or grams per milliliter or things like that. But healthcare makes use of them. That's what IV bags turn out to be. In food, you basically make solutions. So if you have syrups or stuff like that, or molasses, usually sugars show up in terms of solutions. Or if you have dyes, those tend to be super concentrated solutions, so they have high amounts of solutes per solvent. Manufacturing, like if you're making fertilizers, you have to utilize solutions. If we deal with water treatment, we use solutions. There's very little that exists in terms of jobs where solutions don't show up in some way, shape, or form. So one of the tasks that you're going to be asked to do is you're going to be asked on Friday to make a solution. This is going to be your lab. This write-up is really simple. It's going to be, make me this concentration of a solution in this volume. Go do it. So what we have to do is, we have these 8 steps. So it helps if we know what we're adding and what we're adding it into. So usually it's going to be some type of solid into water. It helps if we know the molar mass of what we're adding into the water, the solute. What we then need to do is figure out, if I know the mass, can I figure out a volume and a concentration? Because if I can figure out volume and concentration, typically you're told that. Make a 0.1 molar solution that's 300 milliliters. I need to have volume and concentration so I can calculate moles. Moles turn out to be molarity times volume. Once I have moles, I can figure out the grams of solute, which is just moles times the molar mass. I get that number of grams. I add it into a certain type of flask called a volumetric flask. These are insanely expensive. If you break them, we do not react nicely because they're very expensive. And then you just add water till it reaches that little black line. So this one here on the left says 1,000 milliliters, so a liter. If you fill it up to that black line, that is exactly 1,000 milliliters. You fill this one up to that line, it's 500 milliliters, 250, 100 milliliters. So adding water, the shorthand is you write Q's, meaning fill up until you get whatever volume you need. How much water do you need? I don't know. Fill it up. So here, if I put in 100 grams worth of stuff, I don't add 1,000 milliliters of water because that 100 grams takes up space. So I'm actually going to add less than 1,000 milliliters. So here's some problems that we could try. So I'm going to show you 3, and then it's going to be you're going to work out some 3. The first one is what concentration. So I give you these 2 solutions. Which one's more concentrated? So I have 0.3 grams of, or 0.3 moles of glucose and 300 milliliters of water, or 18 grams of glucose and 50 milliliters of water. So to do this, I just need to figure out moles per liter. So the first one, it's 0.3 moles out of 0.3 liters, because 300 milliliters is 0.3 liters. 0.3 divided by 0.3 is 1, so it's 1 molar. Okay. For this one here, the second one, 18 grams, I need to turn into moles. So that'd be 18 grams out of 180 grams, which gets me 18 out of 180, gets me 0.1. This math should not be difficult. We've done this before. So it gets you 0.1 moles. Well, now I have 0.1 moles out of 0.05 liters, because 50 milliliters is 0.05 liters. That gets me 2 molar. So which one is the more concentrated? The second one, the 18 grams of glucose. That is more concentrated than the 0.3 moles. Another one. So how many grams are in 250 milliliters of a 0.4 molar copper chloride solution? So to do this, step 1, I have volume, I have molarity, I can figure out moles. So if I figure out moles, I can then figure out mass, because that's what you did here. We're just working backwards. So moles would be 0.25, because that's a quarter of a liter, 0.25 liters, multiplied by the 0.4, so 0.4 times 0.25 gets me 0.1 moles. If I could figure out the molar mass of copper chloride, I just take the mass of copper chloride times 0.1, and that'll get me my grams. So moles times molar mass, 0.1 moles times, I have 2 chlorines, each chlorine is about 35.5. The copper is about 63.5, so if I add up all those 3, multiplied by 0.1, I get 13.4 grams. Last one. Tell me how you would make this solution. So you have 600 milliliters of a 0.2 molar sodium fluoride solution. How do I pull it off? So I have volume, I have concentration. If I multiply these 2 together, I'll get moles. If I have moles, I can figure out mass. Then all I have to do is add that mass to a flask and fill it up till I get 600 milliliters. So when we do this, I multiply these 2 numbers. 600 milliliters is 0.6 liters. Molarity is 0.2. 0.2 times 0.6 gets me 0.12 moles. I can take my 0.12 moles, multiply it by the mass of 1 mole of sodium fluoride. So moles times molar mass. We take the 0.12 moles, multiply it by the mass of sodium fluoride, which is sodium's 23, Fluorine is 19 grams per mole, that's 42. 42 times 0.12 gets me 5 grams. So what I do is I add 5 grams into a flask, add water until I get to 600 milliliters, and then mix it. That's all you have to do in order to make the solution. So the next 3 problems are going to be paused, and you're going to have a chance to work on your own, and then we'll go through the answers. So here's example number 1. Here's number 2. And here's number 3.